I think the easiest way to start is to copy all of these. I use Option Command up arrow to get to the implementation file, and I'm going to paste them right under the implementation statement. Okay, now that all that's done, let's look at the code that we have to use to create a setter method. Well, first we're going to say if the username does not equal name, we're going to release the current username that we have, and then we're going to copy the new value coming in. The reason we use copy is because we're asking for an NS string to be sent to us. But in case we get an NS mutable string, we're going to want a copy of that, which will then copy over an immutable string. So this is the way we want to do it for NS strings. Now the getter method is very simple. We're just going to return the username. And that's all there is for that. Now for the user pass, we do the same thing. We're going to say if user pass does not equal the new value coming in, we're going to release our current variable, and we'll make a copy of the new one coming in. And we do the same thing for our getter method. We'll just return user pass. Now, if you're thinking that that's a lot of boilerplate code to write for each instance variable, you're right. Apple thought so as well, and that is where property and synthesize come in. Now let's rewrite this code to take advantage of the property and synthesize methods. So let's go back to the interface file, and I'm just going to take all of this right here and delete it. And I'm going to create a property, and we'll call it copy. And I put in NS string and username. Now that's the exact same thing as what we had before. Since we're going to use this exact statement for the user pass, I'll just copy this, paste it, and put in pass at the end. So these 2 lines now have replaced the 4 lines that we had before. Now what's even better is how much it replaces in our implementation file. So let's use Command Option up arrow to get back to there. And let's go to the top, and I just want to show you how easy this is going to be. We're going to type in synthesize, and we're going to type in username, put a comma, user pass, end it with a semicolon. And now that one line has replaced all of those methods. That's pretty amazing. So we can go ahead and highlight all of these and delete. Now you have to admit that is a lot of code to not have to write. There's a few more things I want to say about property and synthesize, so let's head on over to Keynote and talk about that now. The access specifiers determine whether a getter and a setter are created or just a getter. Now the default behavior is read-write. That will create both. If you specify read-only, then only a getter is created. So in the example that we just had, we only had copy. We didn't actually put read-write or read-only. Therefore, the default behavior was assumed and both were created. If we look at our examples here, in the first example, when you only specify retain, the read-write specifier is assumed and that default behavior is used. Both are created, the getter and the setter. In the second example, we are explicitly stating that only a getter should be created. There are 3 memory specifiers that you can use for dealing with memory. Assign is the default behavior and uses simple assignment. This is typically used for scalar types like integers. Retain invokes retain on the receiver. This will increase the object's retain count by 1. A release message is sent to the previous value. Copy invokes copy on the object. This means that the object is copied using the copy protocol, and that the object being copied must implement the copy protocol. A release message is also sent to the previous value. Atomicity. Atomic is the default behavior and assumed unless you use non-atomic. Now, atomic guarantees that the activity of getting and setting a variable will complete before letting another thread do the same thing. This does not guarantee that your application will be thread safe, but merely guarantees that when a process is getting or setting the value of a variable, It will complete its task fully before another thread can get or set the value. Now there is a performance price to pay for atomic behavior. By the way, there is no keyword to denote atomic. This is the default behavior unless you specify non-atomic. Now non-atomic does not guarantee what atomic does. If you are not creating a multi-thread application, then non-atomic is the way to go, since there is less overhead when using it. It's faster. When we get back to our application, we'll add non-atomic to our property declarations as well.